Good morning, good noon, good afternoon, good evening, whenever and wherever you are. This is Dr. Z from Okayama University, Japan. Today's video is a devlog for our GEO data download software developed by BSGOU, the Bioinformatics study group in Okayama University. We named it GREP1, short for GEO Retrieval and Extraction Pipeline in one shiny app. The name also pays tribute to the gene GREP1, glycine-rich extracellular protein 1. And of course, GREP is a well-known Linux command used to extract specific patterns from large text files, making it a perfect match for our tool. In this video, we will briefly introduce the main features of GREP1. First off, as you can see here, this is a live monitor of R console in real time. Yes, a real-time R console monitor inside a Shiny app. Many Shiny developers have wished of having such a feature. I've seen a lot of posts on forums asking for it, but none of the available solutions were quite satisfying. So we built it our own. That said, this isn't today's main topic. I will cover how we made it work in a future devlog. Now, if you are using GREP1 through our Local Allocation Controller, LAC for short, yes, another gene name, this time from E. coli. You can enable the email notification function. This will automatically notify you when a computing task finishes or fails. For example, here's a quick demo. I will trigger an intentional error and boom, you will get an email telling you the task has failed. The use of this software is quite intuitive. Just type the target GSE number here, and if you have multiple GSE numbers, separate them with white spaces. And don't forget to set up your working directory. Then click the Get ID List button. After that, just wait for a few minutes or even hours, depending on how many samples are under that GSE entry. Once the process is complete, you will see this detailed table which maps the IDs from GSE to GSM to SRA to SRR. But what we are actually downloading here are the files corresponding to the SRR entry, but in SRA format. This live console panel retains only the most recent 2000 lines for performance, but you can download the full console output at any time by clicking the Download Console Log button. As the members of BSGOU and Okayama University, you also have access to our online NAS, where you can check, upload, or download your processed data. Here, for example, we are uploading our downloaded log file directly to our working directory on the online NAS. Finally, to start downloading the SRA files, if you want to download all of them, just leave the table as is and click the Start Download button. If you only want specific entries like showing here, simply select the corresponding rows before starting the download. Once the download is complete, you will find all the SRA files in your online working directory. It may look a bit confusing at first, figuring out which file corresponds to which sample isn't exactly straightforward, right? But don't worry, in our workflow manager, each SRA file is fully traceable back to its GSM and GSE IDs. You can also check their corresponding entries directly in the GEO database with just a click. After the download finished, we move to the next module called SRA Decompressor to extract the FASTQ files from the SRA files based on the FASTQ dump software developed by NIH USA. And again, don't forget to download and upload your console log for debugging if any errors happened in the future. And the first, take a look at this rename column. The values under this column control the file names of your resulting FASTQ files from the FASTQ dump software. And you are free to rename them as you like, but to avoid errors in the downstream analysis, it's important to follow some basic naming rules, such as number 1, keep names within 25 characters. Number 2, use only dash or underscores as symbols. For 10x single-cell RNA-seq results, only use dash, not underscores. And number 3, start each name with an English letter. Do not start with a symbol or a number. Number 4, use only half with English letters, numbers, dashes, or underscores. Avoid full-wise characters or special symbols. Stick to these rules, and your file name will be compatible with other pipelines in the software ecosystem of the BSGOU community. The decompression step usually takes a long time, but don't worry again if you are using GREP through our Local Allocation Controller, LOC for short. You are able to receive email notifications, as shown here. Finally, you will receive these 3 emails for our first, second, and final decompress steps, respectively. During this long decompression step, let me briefly introduce the system of LOC. LOC is a computer resource management system within our campus network designed to manage not only Shiny apps, but also various AI tools and the RStudio online IDE running across multiple machines. Here's a quick demo showing how user access permissions are controlled within LOC. Here's an example of using a Fanning AI tool on our LOC platform. This AI can convert your hand drawing into a vector graph. In LOC system, users' access to workstations or specific software is also regulated based on GPU, CPU, and physical memory usage, as well as the current load from other users. And here is another example of using RStudio-server through LOC. Looks like I forgot to set up the LOC system properly for me to use this RStudio-server, but don't worry, we can fix it quickly at the backend manage panel of LOC system. Alright, here we go. Now we can use the RStudio with full access to our online NAS. Since your data is stored online centrally, it doesn't matter which machine you are using because all BSGOU machines share the same programming environment, including identical versions of Python, R, PyTorch, TensorFlow, Conda environment, and all other essential tools. With this LOC system, any workstation from any department and Shikata campus of Okayama University can be connected to form a unified internal computing resource sharing network. LOC continuously monitors the status of each workstation and can restrict users' access based on the available memory, CPU, GPU usage, and user group permissions, ensuring fair and efficient resource allocation across the network. If you prefer not to use the lock system, you can also run GREP1 on your own Linux machine. The aligner input text file generated here is used for our automatic pipeline for bulk RNA-seq analysis, especially useful when you are integrating single-end and paired-end FASTQ files in the same analysis. I will demonstrate how this works in a future devlog. Alright, that's all for today's video. Whenever and wherever you are, this is Dr. Z from Okayama University. Have a great day, a relaxing evening, or a peaceful sleep.